mental division in Key Stage 2, we're piggybacking on multiplication constantly because we're thinking about the division facts. And the fact that we know our times tables means that we know division facts. So if we know that 7/8 is 56, then we also know that 56 divided by 8 is 7. And that is actually the same how many 8s is 56 is the same fact. It's not different. Division and multiplication are inverse operations. If we know one, we know the other. So division facts just as important as multiplication facts. Just as important that half the tables tests we do have division facts in them, not just multiplication facts. So children are constantly not just knowing 7/8, but knowing how many 8s in 56. So those two things run side by side, and we're practicing them in the mental maths, in the quick maths that we do in the 10 minutes a day. We're really keeping those on the boil. And so then we're using this notion of division as multiplications with holes in to do more complex divisions. When we're saying, well, look, all right, how many 5s is 87? Well, is it more than 10? Oh, yeah, it must be more than 10. Well, let's get a whole load of 10 of them and take them out. And what have I got left? Well, I've got 37. Well, how many 5s could I get out of that? Well, I could get 7 5s, couldn't I? So actually, what I've got is 7 5s and 10 5s. I've got 17 5s and I've got a remainder of 2. Now, it will depend how I constitute that remainder. I may want to make it 17 and 2/5. I may want to round it up. If I'm asking how many buses I will need, and each bus holds 5, or how many big cars I will need, and each car holds 5 children to transport 87 children, well, actually, I'm going to need 18 cars because I can't have 2 running along behind. But if I'm asking how many full boxes of chocolate stars I'm going to have, if I have 5 chocolate stars in each box, well, actually, I'll only have 17 full boxes. And there'll be 2 loose stars. So it depends whether I'm rounding up, whether I'm rounding down. Subsequently, we will even want to write that as a decimal. We will want to know that that is 17.4, and we'll be using our fraction decimal equivalents to get that. So we're developing a system of what I might call mental chunking to use this notion of a multiplication with a hole in to get efficient mental strategies in division and have a really good idea of what division is, so that I can use that idea in going on to do more complex divisions. At the same time, I'm also further developing that whole part of division which is to do with doubling and halving, which is, if you like, to do with sharing. And this is making the connection between fractions and division. So that if I'm doing 1/3 of 81, I understand that I can do that by dividing 81 by 3. That is the same calculation as that. Now, understanding the connection there is quite complex. And it is sometimes hard for children to make the connection between divisions and fractions, but it's very important. So we constantly want to be developing the halving and doubling side of multiplication and division, and the function machine, the idea that actually if we double these numbers, then they turn into these numbers. If we halve these numbers, they turn back into these numbers. That notion of a function machine where we can go forwards, we can go backwards, we've got a function, we've got an inverse function, is really, really fundamental. And once we've got doubling and halving on the map in that function machine way, we can also find quarters. So we can divide by 4 by halving twice. We can divide by 8 by halving 3 times. We can divide by 5 by dividing by 10 and doubling. So we've got all sorts of strategies at our disposal once we've made those connections. So we make the connections between fraction and divisions. We also build up our mental division strategies. And in those 2 ways, we can come to a place where children can start to do written division with some confidence in terms of their understanding of this operation.